Hey friends, welcome to the YouTube channel All About Electronics. So in the earlier video of the clipper circuit, we have seen that what is clipper circuit and we have discussed the different types of clipper circuits. Now when the clipper circuit is designed using the diode and the resistor, then it won't behave like a perfect clipper circuit. For example, ideally this passive clipper circuit should completely remove this negative half cycle. But due to the voltage drop across this diode, we will get this type of waveform. That means using this passive clipper circuit, it is not possible to perfectly clip the waveform at the particular reference level. And to achieve that, the active clipper circuit can be used. So in this video, we will discuss the different types of active clipper circuits which are designed using the op-amp. And as it is precisely able to clip the waveform at the particular reference level, this circuit is also known as the precision clipper circuit. So if we see this circuit, then it consists of the diode, the resistor and the reference voltage. Now here, this reference voltage can also be derived from the supply voltage. But for that, the supply voltage should remain very stable. But in general, we can draw the same circuit like this. Now if you observe the circuit, here the diode is connected in the feedback path. So if we see this portion of the circuit, then it will behave like a super diode. So whenever the diode is in the on condition, then the op-amp will operate in the closed loop configuration. And due to the very high gain of the op-amp, the voltage drop across this diode is negligible. So basically this diode will act as an ideal diode. And we have already seen this concept in the earlier video of the precision rectifier. So for more information you can check that video. So in short, in the closed loop configuration, the op-amp will behave like a buffer circuit, and due to that, the output will follow the input signal. And whenever this diode is in the off condition, then the op-amp will operate in the open loop configuration. So now let's understand the working of this circuit by applying the sine wave as an input signal. So here let's say a sine wave with a peak value of Vm is applied as an input signal, and here Vref is the reference voltage. And first of all, let us see what happens whenever the input voltage is less than the reference voltage. Now if you see over here, the voltage at the inverting terminal of the op-amp is equal to the reference voltage, because as we know, the no current will flow into the op-amp terminal, and due to that there won't be any voltage drop across this resistor R1. So due to that, this reference voltage will directly appear across this inverting terminal, and here the input voltage is applied at the non-inverting terminal. So whenever the input voltage is less than the reference voltage, so we can say that at that time this voltage V plus is less than the V minus, and due to that momentarily the output voltage of the op-amp will go towards the negative saturation, and here the voltage at the anode of the diode is equal to the reference voltage. So due to that, whenever the input voltage is less than the reference voltage, at that time the diode starts conducting, and due to that the op-amp will operate in the closed loop configuration. So we can replace this diode by the short circuit, and in this case if you see, now the output voltage will follow the input signal. That means whenever the input is less than the reference voltage, at that time the output voltage will follow the input voltage. Now just after this point, the input voltage will be greater than the reference voltage. So at that time we can say that the voltage V plus is greater than the V minus. So in this condition, whenever the input is greater than the reference voltage, the output of the op-amp will go towards the positive saturation voltage. And if you see over here, the voltage at the anode of the diode is equal to V reference. And as V set is greater than the V reference voltage, so this diode will act as a open circuit. So due to that, now the op-amp will operate in the open loop configuration, and the output of the circuit is equal to the reference voltage. So whenever the input voltage is greater than the reference voltage, at that time the output of this clipper circuit is equal to the reference voltage. Now once again after this point, the input voltage will be less than the reference voltage. So once again, now we can say that this voltage V plus is less than the V minus. So once again, now the op-amp will go towards the negative saturation voltage, and due to that, now once again this diode will start conducting. So in the closed loop configuration, we can replace this diode by the short circuit, and once again during this period, the output voltage will follow the input signal. So in general, for this active clipper circuit, if we apply the sine wave with a peak value of Vm, then at the output we will get this type of waveform. So in general, for this clipper circuit, we can say that if V reference is the reference voltage, then the any waveform which is greater than the reference voltage will get clipped. Now in the same circuit, let's find out the output waveform when we reverse the polarity of this reference voltage. So here this minus V reference is the reference voltage and this is the input signal. And if you look over here, starting from 0 up to this point, the input voltage is greater than the minus V reference. So we can say that at that time this voltage V plus is greater than the V minus. So due to that, during this time the output of the op-amp will go towards the positive saturation voltage. And as the anode of the diode is at minus V reference voltage, so during this period the diode will act as an open circuit. So during this period the output voltage of this circuit is equal to minus V reference volt. Now after this point, the input voltage will be less than the minus V reference voltage. So during this time we can say that now the voltage at the V plus is less than V minus. And during this period, now the op-amp will go momentarily towards the negative saturation voltage. That means during this period, momentarily the voltage over here is equal to minus V set. And as the minus V set is less than minus V reference, so we can say that during this period the diode starts conducting. And due to the closed loop configuration, we can replace this diode by the short circuit. So during this period of the signal, the output voltage Vout will follow the input waveform. And if we see the waveform, then it will look like this. Now once again, after this time, the input voltage Vin will be greater than the minus V reference. So once again, now this voltage V plus will be greater than V minus. And due to that, once again, the op-amp will go towards the positive saturation. So during this period, once again the diode will act as an open circuit, and now the output voltage Vout is equal to minus V reference. So in general, if we see the output waveform of this active clipper circuit, then it will look like this. That means this circuit will clip the any waveform which is greater than the minus V reference. So in general we can say that whenever the diode is connected in this fashion, then the circuit will clip anything which is above the reference voltage. Now let's see what happens when we reverse the direction of this diode. So in this circuit, the input voltage is the sinusoidal signal and the reference voltage is equal to minus V reference. So starting from 0 up to this point, the input voltage Vin is greater than the minus V reference. Or we can say that during this period, the voltage V plus is greater than V minus. So due to that, momentarily, the op-amp will go towards the positive saturation voltage, and due to that, now this diode starts conducting. So during this period of the signal, now the output of the op-amp will follow the input signal. And if we see the output waveform during this period, then it will look like this. Now after this point, now the input voltage is less than the reference voltage. Or we can say that during this period, now the voltage V plus is less than V minus. So during this period, now the op-amp will go towards the negative saturation voltage, and due to that, now this diode will act as an open circuit, because at that time the voltage at the anode, which is minus V set, is less than minus V reference, and due to that the op-amp will act as an open circuit. So whenever the input voltage is less than the minus V reference, then the output voltage Vout will be equal to minus V reference. Now once again after this point, the input voltage Vin will once again become greater than minus V reference. So at that time, once again, the voltage V plus will become greater than V minus. So due to that, now the op-amp will once again go towards the positive saturation, and due to that we can replace this diode by the closed switch. So during this period, when the input voltage is greater than the minus V reference, at that time the output voltage will follow the input waveform. So in general, if we see the output waveform of this clipper circuit, then it will look like this. That means this circuit clips the any waveform which is below the minus V reference. Now in the same circuit, let's see the output waveform when we reverse the polarity of the reference voltage. Now in this case, whenever the input signal starts, at that time the input voltage will be less than the reference voltage. So at that time voltage V plus will be less than V minus, and during this condition the output of the op-amp will go towards the negative saturation because the voltage at the inverting terminal is greater than the non-inverting terminal. So due to that, now the op-amp will act as an open circuit, and during that time the output of this circuit will be equal to V reference. Now after this point, the input voltage V in will be greater than V reference, and due to that we can say that now this voltage V plus is greater than V minus. So during this time, whenever the input is greater than V reference, the output of the op-amp will go towards the positive saturation, and due to that now this diode starts conducting, and we can replace this diode as a closed switch. So when the input voltage is greater than the reference voltage, at that time the output will follow the input waveform. And once again after this time, when the input is less than minus V reference, this voltage V plus will become less than V minus, and due to that now the op-amp will go towards the negative saturation, and due to that the diode will act as an open circuit. So once again now the output voltage V out will be equal to V reference. So in general, the output waveform of this circuit will look like this. That means this circuit clips the any waveform which is less than the reference voltage. So in general we can say that in this active clipper circuit, whenever the diode is connected in this fashion, then it clips the waveform which is less than the reference voltage. So in this way, by changing the direction of the diode and the polarity of the reference voltage, we can use this active clipper circuit as per our requirement. And more importantly, using this active clipper circuit, we can eliminate the voltage drop across this diode. So here is the simulation result of one of the circuits which we have discussed during the analysis. So in this circuit, the input signal is a 5 volt sinusoidal signal and the reference voltage is equal to 3 volt. So as you can see in the waveform, this blue waveform is the output waveform and the green waveform is the input waveform. So basically this circuit clips the any waveform which is less than 3 volt. So in this way, using this active clipper circuit, we can precisely clip the portion of the waveform which is above or below the reference voltage. So I hope in this video you understood how we can design the active clipper circuit using the op-amp. So if you have any question or suggestion, do let me know here in the comment section below. If you like this video, hit the like button and subscribe the channel for more such videos.